Hello everyone. In this video, we'll be seeing linear PDE of homogeneous type two problems. That is, the right hand side will be either sin ax plus by or cos ax plus by. So if we have the right hand side as term as sin ax plus by, then the particular integral we can find it by replacing d square with minus a square, d dash square with minus b square, and d dash with minus ab. That is, we have to replace d square as minus a square and d dash square as minus b square and d dash as minus ab. So if the denominator is equal to 0, similar to type 1 problem, we have to differentiate the denominator and we have to multiply particular integral with x. So f dash of d comma d dash is nothing but derivative with respect to d. D dash will act as a constant. So similarly, we can do the same procedure for cosine right hand side terms also. So let us take the first question. Solve d square plus 9 d dash square into z equal to cos 2x plus 3y. Auxiliary equation will be m square plus 9 equal to 0 and our roots are, we can write m square is equal to minus 9. So m can be written as root of minus 9. M is equal to plus or minus 3i. So m can be 3i and minus 3i. So complementary function, even though it is imaginary part, we can write complementary function in the same manner. Cf will be equal to f1 of y plus 3ix plus f2 of y minus 3ix. Now to find the particular integral is nothing but 1 by d square plus 9 d dash square into cos of 2x plus 3y. Now comparing this cos term with cos of ax plus by, we know that d is a and d dash is b. And we have to replace. The rules are d square with a square, a value is 2 and b value is 3. So d square will be 4 minus 4. D square should be replaced with minus a square. D dash square with minus b square, which is minus 9. And then d dash with the minus ab. Minus ab is nothing but minus 6. So we can write it as 1 by d square is minus 4 plus 9 into d dash square is minus 9 cos of 2x plus 3y. This is equal to 1 by minus 4 minus 81 cos of 2x plus 3y. This is equal to minus 1 by 85 cos of 2x plus 3y. So since our denominator is non-zero, we can accept that this will be our particular integral. So the complete solution is z equal to cf plus pi. Now let us come to the next question. Solve d square minus 2d d dash plus d dash square into z equal to sin 2x plus 3y. So finding auxiliary equation, that is m square minus 2m plus 1 equal to 0 and the roots will be 1 and 1. These are repeated roots. So CF is f1 of y plus x into f2 of y plus x. Now to find the particular integral, pi will be equal to 1 by d square minus 2d d dash plus d dash square into sine of 2x plus 3y. Comparing this with the general form, we will get a is equal to 2 and b is equal to 3. So d square, it can be replaced with minus a square, that is minus 4, and d dash square, we can replace it with minus b square, so we will get minus 9. D dash, we can replace it with minus ab, so it is minus 6. We will get 1 by d square is minus 4 minus 2 into d dash is minus 6 plus d dash square is minus 9 into sine of 2x plus 3y. This is equal to 1 by minus 4 plus 12 minus 9 sine of 2x plus 3y. This is equal to 1 by 12 minus 13 sine of 2x plus 3y. We can write it as minus sine of 2x plus 3y. Since the denominator is non-zero, this will be our particular integral. So complete solution can be written as CF plus PI. Now coming to the next question, we know that dou by dou x will be replaced with capital D and dou by dou y. That is dou by dou x will be capital D and dou by dou y will be capital D dash. So this question can be replaced with d square plus d dash square into z equal to cos 2x cos 3y. So the auxiliary equation is m square plus 1 equal to 0. We can write it as m square is equal to minus 1. So our m value will be plus or minus I. So the complete complementary function is f1 of y plus ix plus f2 of y minus ix. Now to find the particular integral, first we have to write this cos A cos B term in sum of sine and cosine terms. We know that cos A plus B. So cos A plus B equal to cos A cos B minus sine A sine B. And cos A minus B is cos A cos B plus sine A sine B. So we can write cos A cos B as 1 by 2 cos of A plus B plus cos of A minus B. So here comparing this term with our question, we can take A term as 2x and B term as 3y. So we'll get cos 2x cos 3y as 1 by 2 cos of 2x plus 3y plus cos of 2x minus 3y. So next, writing particular integral, the same thing, 1 by d square plus d dash square cos 2x plus cos 3y. So this can be replaced with 1 by 2 cos of 2x plus 3y plus cos of 2x minus 3y. Since this 1 by 2 is a constant, I can take it outside the integral. So now multiplying this 1 by d square and plus d dash square inside, we'll get this part. See, in this part, for the first part, d square will be replaced with minus a square, that is minus 4, and d dash square will be replaced with minus b square, that is minus 9, and d dash with d dash term is not there, so no need to replace it. And second also, second term d square will be replaced with minus 4, d dash square will be replaced with minus 3 the whole square, which is 9. So b square is 9 and then d dash square will get minus b square. This is equal to 1 by 2 into 1 by minus 4 minus 9 cos of 2x plus 3y plus 1 by minus 4 minus 9 into cos of 2x minus 3y. Now this term will be minus, here we can write it as minus 13, here also it is minus 13. If we take both the minus 13 times outside, so it is minus 1 by 26 cos 2x plus 3y cos 2x minus 3y. Note that we should not leave up to this step. We have to bring the particular integral in terms of the right hand side term given in the question, that is cos 2x cos 3y. Now cos a plus b plus cos a minus b can be written as twice cos A cos B. So 2 and 26 will get cancelled. Our solution is minus 1 by 3 cos 2x cos 3y. The complete solution, we can write it as complementary function plus particular integral. So this will be our complete solution in this problem. Now d square plus d dash minus 6 d dash square into z equal to cos of 2x plus y. So this is our auxiliary equation. We can write it as m plus 3 into m minus 2 equal to 0. So our m values will be minus 3 comma 2 or 2 comma minus 3. So the complementary function will be f1 of y plus 2x plus f2 of y minus 3x. To find the particular integral pi, we can write 1 by d square plus d dash term minus 6 d dash square into cos 2x plus y. This here we can replace d as 2 and d dash as 1. So d square will be replaced with minus 4 and d dash square will be replaced with minus 1. D dash will be replaced with minus 2. So it is 1 by minus 4 d dash with minus 2 and d dash square with minus 1 minus 6 into minus 1 it is plus 6 cos of 2x plus y. So we'll get 1 by 0 cos of 2x plus y. Since we are getting 0 in the denominator, next step we have to write the derivative, that is pi. We can write it as x into 1 by, so if we differentiate the denominator with respect to d, we'll get 2d plus d dash is a constant, so we'll get d dash, and minus 6 d dash square is constant, it will become 0 cos of 2x plus y. So now the same thing, we have to replace d square with minus 4, d dash square with minus 1, d dash with minus 2. But observe that there is no d term, no d dash square term and no d dash term in denominator. So but we have to bring d square, d dash term, d dash square terms in denominator. How to do that? We are going to multiply with its conjugate 2d plus d dash into 2d minus d dash divided by 2d minus d dash into cos of 2x plus y. That's what we written here. So here we are going to multiply with 2d minus d dash divided by 2d minus d dash. So in numerator we will get 2d minus d dash. Denominator it is in the form of a plus b into a minus b. So we will have a square minus b square. A square is 4d square minus b square is d dash square. We know that d square will be replaced with minus 4, d dash square will be replaced with minus 1. So minus 4 into 4 it is minus 16, minus 1 into minus 1 it is plus 1. So we will get minus x by 15. Now we can multiply this cos 2x plus y term once with this part and next with this part. So it is 2d cos of 2x plus y minus d dash cos of 2x plus y. Observe that d means differentiating with respect to x, d dash means differentiating with respect to y. So we have to use the composition rule. If we differentiate cos, we'll get minus sign. So I'll do this part alone. Cos 2x plus y. 2. If we differentiate cos, we'll get minus sign of 2x plus y, and then we have to differentiate the term inside the bracket with respect to x. So we'll get 2. This is equal to minus 4 sine 2x plus y. Similarly, for this part, cos derivative will be minus sign, minus into minus will become plus, and if we differentiate with respect to y, it will get 1 because only y term is there. So minus 4 sine 2x plus y plus 1 sine 2x plus y, which will be minus 3 sine 2x plus y. So minus into minus will become plus, If we cancel this part, we'll get the answer x by 5 sine of 2x plus y. Now the complete solution is complementary function plus particular integral.